So in this problem, we are looking at in the region of 80% of the in a region, 80% of the population have brown eyes. If 14 people are randomly selected, find the probability that at least 12 of them have brown eyes. Is it unusual to randomly select 14 people and to find at least 12 of them have brown eyes? Why or why not? Okay, so there's a key word here that I just want us to focus in on, and it's the fact that we are finding the probability that at least 12. So I'm going to go down a little bit. Oops. And we're going to talk just what that means to be at least 12 of them have brown eyes. So you're going to pick 14 people, right? And let me make this a little bit bigger. At least is greater than or equal to 12, right? Because if I need to have at least 12 people with brown eyes, it would be okay if we had 12 or 13 or 14, right? Because we're going to pick 14. We want 12 or more. So another way to say greater than or equal to, or at least greater than or equal to, or 12 or more. So when we do our binomial PDF probabilities here, we're going to need to do binom PDF. Again, n is the number of trials, right? How many people are we picking? We're going to pick 14, comma. What's the probability that somebody has brown eyes? That's 80%, but we don't use 80, we do 0.8. And then, how many am I looking for? Greater than or equal to 12. So what's going to happen here is I'm going to need to get 3 different ones. So we're going to do it with 12. Same setup here, 14. 0.8 is the probability. Now, also could be 13. Then we're going to finally do it again with 14, comma 0.08. Sorry, 0.8, comma 14. Because when we say greater than or equal to 12, that's all of the numbers greater than or equal to 12, right? Now we're going to go over to our calculator. I'm going to do this 2 ways. I'm going to show you guys how to do this if you have a TI-83, and then I'll show you what it should look like in an 84. So I go to second bars. We're going to go down. Listen, it might be A, it might be 0. I don't know what letter it's going to be for you, but what you're looking for is you're looking for the function binomial PDF, and you can see it's right here. You see it right here. It's A for me, but just look for these words, binom PDF. When you click enter, some people, if you have an 84, it's going to be taking you to this screen where it's going to go, you're going to put 14 for your number of trials, you're going to put 0.8, and then we need to do this 4 separate times, so we'll first do it for the number 12. And then I'm going to paste that in there. If you have a TI-83, when you hit enter there, what it does is it just takes you to this screen, and what it will look like is this right here. And then you're just going to make it look exactly like the way I set it up over here. We're going to do 14 and then a comma and then 0.8 and then a comma and then 12. And what did I get for this one? I got 0.2501. All right. Now I'm going to get the next one. We're going to do this with 13. I'm going to show you a little trick that's really helpful. If I hit second and then the enter button, it's going to recall what I had. And now I'm just going to be doing it. Everything, it's going to be 14 trials, 0.8% probability of success. And this time I'm looking for 13 successes. And that gave me 0.1539. All right, one more here. We're going to do it with 14, the probability of picking 14 people and having all 14 of them have brown eyes. And that would be 0.04. If we're going to round, it's going to go 40, right? Because when I look at this, if we're going to round 4 decimal places, this 9 is actually going to round up to a 10, which makes that 3 to 4. So basically we're rounding that 39 up to a 40. Now what you need to do here is you're finding the probability that either 12 or 13 or 14, so we are going to add these up right here. So we're going to add 0.2510 plus 0.1539 plus 0.0440. And 0.4489 would be the probability that we have at least 12 of those people having brown eyes. That is obviously not unusual because that's 44.89%, right? So just probability that at So this is what we were being asked, and we found that by doing all three of these, and when you add them up you get 0.4489 or 44.89%. Again, I hope this is helpful. Just focus in on how many trials, what's the chance of success, and if you see at least or at most, know it's going to be an inequality here.